OK Mathematics class, training you to excel. Welcome to OK Mathematics class. This is our step-by-step to exam solution. Step number 1, plan. Step number 2, pray. Step number 3, prepare. Step number 4, preview. And step number 5, perform. Please support this channel by subscribing, give a thumbs up, and share with friends. In this presentation, we are looking at WAEC May June 2010, questions number 10 to 13. Question number 10, algebra, quadratic graph. Question number 11, geometry, areas of triangles and quadrilaterals. Question number 12, statistics, cumulative frequency curve. Question number 13, number and numeration, geometric progression, and also algebra variations. Now let's go straight to question number 10, WAEC May June 2010. Copy and complete the table of the values for the relation y is equal to minus x squared plus x plus 2 for the values of s from minus 3 to plus 3. This is the table. 10b, using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis, draw a graph of the relation y is equal to minus x squared plus x plus 2. 10c, from your graph, find the maximum value of y. Roots of the expression x squared minus x minus 2 is equal to 0. 3. Gradient of the curve at a point where x is equal to minus 0.5. Now we import the table, and then we are going to complete the table. The first one, when x is minus 3, we are going to replace the values of x with minus 3 in this relation. We are substituting. On simplification, we have minus 9 minus 3 plus 2, giving us y is equal to minus 10. When x is minus 1, we substitute the value of x as minus 1 in this relation. That's the substitution taking place. On simplification, minus 1 minus 1 plus 2 is equal to y is equal to 0. When x is equal to 1, we substitute x equal to 1 in this relation. Y is equal to minus 1 plus 1 plus 2, giving us y is equal to 2. When x is 2, we substitute the value of x as 2 in that relation. On simplification, y will give us 0. Now that we have completed the table of value, we go straight to the graph board to plot the graph. On the graph board, we are going to draw the scale. That's the scale. Every 2 centimeters represent 2 units on the y-axis, and every 2 centimeters represent 1 unit on the x-axis. We are going to import the table. So now, we are going to start the plotting. The first point, when x is minus 3, y is minus 10. Minus 3 minus 10 will be at this point. When x is minus 2, y is minus 4. Minus 2 and minus 4 will be at this point. When x is minus 1, y is 0. Minus 1 and y 0 will be at this point. So we have all the points now plotted. We are going to join these points with a smooth curve. So that's the quadratic curve. Now we're going to use this quadratic curve to answer question C. The first question there is to find the maximum value of y. This is the greatest value of y. So draw a horizontal line from that point to meet the y-axis. The green line is the horizontal line, and that point is being indicated. So therefore y maximum is equal to 2.3. The root of the equation is where the quadratic curve crosses the x-axis. The first point is here and the second point is here. So therefore the roots are -1 and +2. We are going to find the gradient at the point where x is equal to -5. So at this particular point represented by this blue dot, we are going to draw our right angle triangle. The red triangle is the required triangle. We are going to find the change in x, and that is 1.5. And we are going to find the change in y. That's 1, 2, 3. That gives us 3. The gradient at the point where x is equal to -0.5 would be the change in y, 3, divided by the change in x, 1.5. And on evaluation, gradient will be equal to 2. That's the solution to question number 10. So we are going to move straight to question number 11. 11a. In the diagram, angle PTQ is equal to angle PSR is equal to 90 degrees. PQ is equal to 10 centimeters and PS is equal to 14.4 centimeters. And TQ is equal to 6 centimeters. Calculate the area of the quadrilateral QRST. Now let's see how this problem can be solved. That's triangle PSR. And that's triangle PTQ with all the labels shown. That's the side PS given, and that's the side PQ and TQ also given. We are going to find the side PT. That's PT. We are finding this side PT. So PT squared is equal to PQ squared minus TQ squared. We are going to substitute the values of PQ and TQ. That's 10 squared minus 6 squared. On simplification, that gives us 100 minus 36, which is equal to 64. Therefore, taking the square root of both sides, PT is equal to 8 centimeters. So that PT is equal to 8 centimeters. And remembering that triangle PSR and PTQ are similar triangles. So we're going to use that to take the ratio of the triangles. And those ratios must be equal or must be the same. So let's take the ratio. So the ratio of TQ to PT will be equal to the ratio of SR to PX. TQ is 6, PT is 8, and SR is what we are finding, and PS is 14.4 centimeters. Cross multiplying, this cross multiply this and this cross multiply this, they are going to have 8 times this will give us 14.4 times 6. Make SR the subject. We have 14.4 times 6 over 8. Using calculator, we can evaluate this. Side SR will be equal to 10.8 centimeters. Now that we have gotten that, remember the area of the quadrilateral TSRQ is the area of the big triangle PSQRST. QR minus the area of the small triangle PTQ. So we're going to subtract that. That's the quadrilateral after subtracting the small triangle from the big triangle. So therefore the area of quadrilateral QRST is equal to the area of the triangle PSR minus the area of triangle PQT. The area of the quadrilateral QRST will be equal to half times 14.4 times 10.8 minus half times 8 times 6. On simplification, that will give us 77.76 minus 24. Therefore, the area of quadrilateral QRST is equal to 53.76 centimeters squared. We are going to go to the next slide for the solution of question number 11B. 11B. Two opposite sides of a square are each decreased by 10 centimeters while the other two are each increased by 15 centimeters to form a rectangle. Find the ratio of the area of the rectangle to that of the square. So that is the square. Let the length of that square be x centimeters. So that means each side of the square here will be x centimeters. Now we are going to decrease this side by 10%. That means the new side will be 90%. And we are going to increase this side by 15%, decrease this side by 10%. So now this side have decreased by 10% and this side increased by 15%. So therefore the width of the rectangle will be 90 over 100x, which is 0.9x centimeters in decimal. The length of the rectangle, see the length being highlighted, the length of that rectangle will give us 115 because it has been increased by 15% over 100 times x, which will be equal to 1.15x centimeters in decimal. We are now going to find the area of the square, which is x times x squared centimeters, while the area of the rectangle will give us 0.9x times 1.15x square centimeters. If you simplify that further, you have 1.035x square centimeters. The ratio of the area of the rectangle to that of the area of the square will give us the area of the rectangle calculated already. 1.035x squared centimeter squared is to x squared centimeter squared, dividing through by x squared. We are now going to have the ratio of the areas will be 1.035 is to 1. That's the solution to question number 11. Then we'll go straight to question number 12. Question number 12. The frequency distribution of the weights of 100 participants in a high jump competition is as shown below. That's the table. 12A. Construct the cumulative frequency table. B. Draw the cumulative frequency curve. C. From the curve, estimate 1. The median. 2. Semi-interquartile range. 3. Probability that a participant choosing at random weighs at least 60 kilograms. Let's see how this question can be solved. So we are now going to draw the table to include class boundaries, the class boundary, and the cumulative frequency curve. Our duty now is to calculate the class boundaries and then the cumulative frequency table. So now for the class boundary, the upper class boundary, add 0.5 here, subtract 0.5 here. That will give us a 19.5 to 29.5. Here, add 0.5 here, subtract 0.5 here. That will give us a 29.5 to 39.5. Subtract 0.5 here and add 0.5 here. That will give us that. So the same way you find this, the same way now we have the class boundaries. The lower class boundaries, the upper class boundaries. Then the cumulative frequency for the first class is 10, since there is no class before it. For the second class, the cumulative frequency is addition of the first two classes, 10 plus 18, giving us 28. The next will be the addition of the three classes, first class, second class, and the third class. That is 28 plus 22. Following the same pattern, this will give us 50 plus 25. This will give us 75 plus 16. So that's 75 plus 16. This will give us 91 plus 9. 91 plus 9. Then the total or the cumulative frequency is 100. Now, using the cumulative frequency table and the upper class boundary, we can plot the cumulative frequency graph. Now on the graph board, we are going to choose our scale. Looking at the scale, 2 centimeters is 20, 2 centimeters is 20, 2 centimeters is 20, and here 2 centimeters is 9.5, 9.5, and that continues that way. So now we're now going to plot the cumulative frequency curve. But first of all, let's import the table. So that's the table we're going to use to do the plotting. Now we're going to plot. For upper class boundary of 29.5, the cumulative frequency is 10. So we're going to plot that point, 29.5 against 10. The next will be 39.5 against 28. That will give us somewhere around this point. So we plot that. The next will be 50 against 49.5. 49.5 against 50 will be somewhere here. So we plot the point. So the same way, we're now going to complete the other points. So now these are the points. We're going to join these points with a smooth curve. So that's the curve. That's the cumulative frequency curve. Now we're going to answer the questions. The first question we're asked to answer is to find the median. The median will be in the 50th position. So median will give us the 50% of the cumulative. And if we find 50% of 100, 50% of 100 will give us a 50th position. So we're going to draw a horizontal line from that 50 position, the 50th position, and then we'll find the value on the weight axis. So now let's do that. The dashed line represents that position, and it touched the cumulative frequency curve at this point. So we're now going to select that point and trace it down, giving us the value as 49.5. So therefore the median class is 49.5 kilogram. Question number 12C. We are going to find the lower quartile and the upper quartile. The lower quartile is there 25% of the cumulative, and that gives us a 25%, and it means the curve at this point. So we're now going to trace it down from that point. So the lower quartile will give us 37.5 kilogram. And then we're going to find the upper quartile. The upper quartile Q3 is 75% of the cumulative, or 75% of 100. So that's the line at 75%. So from where the line touched the cumulative frequency curve, we are going to trace it also down. That gives us Q3 as 59.5 kilograms. So therefore the semi-interquartile range is Q3 minus Q1 divided by 2. Put in the values, 59.5 minus 37.5 divided by 2. On simplification, the interquartile range will give us 22 divided by 2, which is equal to 11 kilograms. Now we will now move to question number 3 for C. Finding the probability. Finding the probability. The question says, find the probability that a participant choosing at random weighs at least 60 kilograms. How do we solve this? Going back to the table, you are going to see clearly that 16 participants in that competition weighs between 60 to 69 kilograms, 16 of them. And also, 9 of those participants weighs between 70 to 79 kilograms. So those that weigh 60 and above should not be the addition of these two numbers. So therefore, those that weigh 60 and above will be 16 plus 9 participants. Then therefore, the probability of selecting a participant that weigh over 60 kilograms will give us probability of greater than 60 will be 25 over 100, which is 1 over 4. That brings us to the end of question number 12. Then we'll go to the last question for this presentation. WAEC May June 2010, question number 13. The third term of a geometric progression GP is 24 and its seventh term is 4:20/27. Find its first term. B. Given that y varies directly as x and inversely as the square of z, if y is equal to 4 when x is equal to 3 and z is equal to 1, find the value of y when x is equal to 3 and z is equal to 2. Let's see how we can solve this problem. For 13a, this is the general formula for the nth term of a GP. For the third term, we replace n by 3. So we have u3 given as this equation. That's the value of u3. So we are going to replace u3 with 24. And that gives us 24 is equal to a r squared, equation 1 in blue. The seventh term will give us u7 is equal to ar raised to power 7 minus 1. That means replacing n by 7. Now, picking the value of u7, we're now going to have 4:20/27 will be equal to ar power 6 in orange. Now, dividing the equation in blue, in the orange color with the equation in blue, or equation 2 by equation 1, then we're going to have this divide by equation 1. We are going to simplify that expression by changing the mixed number to improper fraction. That gives us 128/27 is equal to ar power 6 over 24 is equal to ar power 2. Further simplification will give us the expression as shown on the board. Then dividing out, 8 divided 24 is 3, 8 divided 128 is 16. And A divide A, we are now left to A power 6, R power 6, and R power 2. On further simplification, we have 16 over 81 is equal to R raised to power 4. Then we now find the fourth root of that to be able to find the value of R. The fourth root of that, or R power 4, is equal to 16 over 81, rearranging the equation. And therefore the fourth root of R will give us 2 over 3. You can find this also by taking the square root here twice. Take the square root of this, R squared. Take the square root of this, 4 over 9. Take the square root of R squared that you obtained in the first square root, you have R. And taking the square root of 4 over 9, you have 2 over 3. So therefore, the value of R, the common ratio, is 2 over 3. Now, 24 is equal to AR squared using equation 1. Making A the subject, we have that. Substituting the value of R and simplifying, we're now going to get A is equal to 24 over 4 divided by R. Changing division to multiplication and then inverting the fraction. That's changing this to multiplication and inverting this fraction. We have 24 times 9 over 4. On simplification, we have A is equal to 54. Then we go to 11b. Y is directly proportional to x and inversely proportional to the square of z. Replace this proportionality constant with a sign with a constant k, and replace this with equality sign. So therefore, make k the subject. So k will give us a yz squared over x. On further simplification and substitution, we are going to have k is equal to 4 times 1 squared over 3. Using calculator to evaluate that, k is equal to 4 over 3. Substitute the value of k in the original equation, y is equal to kx over z squared. So we are going to have y is equal to 4 over 3x over z squared. On further simplification, y is equal to 4x over 3z squared. This is the law or the formula giving us the relationship between x, y, and z. Now we are going to make direct substitution to find the value of y when x is equal to 3 and z is equal to 2. So therefore, in place of x here, you write 3. In place of z here, you write 2. On simplifying again, we are going to have 4 times 3 is 12. And then 2 squared is 4. 4 times 3 is 12. Dividing out, 12 divided by 12 will give us 1. So therefore, the value of y is 1 when x is equal to 3 and z is equal to 2. Please remember to support this channel by subscribing, give a thumbs up, and share with friends.